Welcome all of you. So today I will give you an idea about how to solve the problem of chi-square. So this is the first problem. Weight of 10 students is as follows. Here you can see serial number. So these are the 10 students, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 students. Their weight in kilogram, 38, 40, 45, 53, 47, 43, 55, 48, 52, and 49. So here in the table, you can see the weight of 10 students. Can we say that, the question is like this, can we say that the variance of the distribution of weight of all the students from which the above sample of 10 students was drawn is equal to 20 kilograms? So this is the question. Variance of the distribution of weight of all students from which the above sample of 10 students was drawn is equal to 20 kilograms. Okay, so the variance is equal to 20 kilograms. So that is the question. You have to check this one. Variance of the distribution of weight of all students from which the above, this is the sample weights of 10 students. So you have to check variance of the distribution of weight of all students is equal to 20 kilograms. So you have to test this at 5% and 1% level of significance. So at 5% level of significance and also at 1% level of significance. So first of all, we should work out the variance of the sample data, or sigma s square, and same has been worked out as answer. So here this is the table. So I will show the table in the board. So I will draw the table. So this is my table. So this is my table, and here this is the serial number. Okay, so this is the serial number. So here number of students 1, 2, 3, etc. up to 10 students. So here this is the 10 students. Okay, then the weight. So that is, say I will write here x1 as weight. Okay, so this is the weight. This is the weight. Okay, so what about the weight? So 38. So the first student, the weight is 38, and second student it is 40. Okay, so etc. So these are the weights, and the weight of the last student, that is 49. Okay, then you have to find x minus x bar. So that is the deviation from mean. So what is the deviation from mean? X minus x bar. So what is x bar? So what is x bar? You have to calculate the x bar. Okay, so x bar means, you have to calculate x bar means, this is the equation, sigma xi divided by n. So x bar is equal to sigma xi divided by n. Sigma xi divided by n. Okay, so sigma xi divided by, so sigma xi means you have to add all these. So you will get this value as 470. Okay, so this is 470. You have to add all these values, so you will get 470. So that is equal to, so sigma I is xi is equal to 470 divided by n means how many, check the number of students, 1 to 10. So 470 divided by 10, so that is equal to 47. Okay, say 47 kilograms. Okay, because x is the weight. So 47 kilogram is the x bar. So you have to find the differences between the x to x bar. Okay, so 38 minus 47. So you will get minus 9. So this value is minus 9. Then the next value is minus 7. Okay, and etc. You have to find all these values. Difference, you have to find the difference. Then the last column, xi minus x bar the whole square. So, okay, so that is xi. So this is xi. So this is xi. So xi minus x bar, xi minus x bar the whole square. So this is 81. This is 49. Okay, so you have to calculate, etc. You have to calculate all the other values. You have to calculate all the other values. Okay. Then you have to find the sigma s, the work out the variance of the sample data, that is sigma s square. Okay, so sigma s square is equal to, okay, so I will write here sigma s square. So that is equal to, sigma s square is equal to root of, okay, square root of sigma, okay, xi minus, so xi minus x bar the whole square, xi minus x bar the whole square divided by n minus 1. Okay, so divided by n minus 1. So what is the value? So what is sigma xi minus x bar? You have to calculate, this is xi minus x bar, so you have to add all these values. Okay, so that is sigma xi minus sigma value. You will get sigma xi minus x bar the whole square here. So this value is 280. Okay, so this value is 280. This value is 280. Okay, so you have to substitute here. This is 280 divide, what is n? N is 10. So 280 divided by 10 minus 1. 280 divided by 10 minus 1. Okay, so that is sigma s square is equal to 31.11. So sigma s square, so that is equal to 31.11. Okay, so that is the value of sigma s square. Sigma s square is equal to 31.11. Okay, then next is you have to write the null hypothesis. Okay, so here the question is, can we say that the variance of the distribution of weight of all students from which the above sample of 10 students was drawn is equal to 20 kilograms? So that is the question. So here you have to write sigma p square is equal to sigma s square. Okay, so sigma s square you have calculated. So the variance of the sample data, so the variance of the sample data you have calculated. Okay, so that is 31.11. Okay, so I will write the hypothesis here, null hypothesis. So H naught, this is the null hypothesis, H naught, sigma P square is equal to sigma S square. Okay. Okay. Then you have to apply the chi-square value. So this is the chi-square. So chi-square is equal to, so this is the equation, sigma S square by sigma S square divided by sigma P square into n minus 1. Sigma S square divided by sigma P square into n minus. So what is sigma S square? That is 31.11. So that is equal to 31.11 divided by 31.11 divided by then sigma P square, that is 20, that is given. Okay. So this is the variance of the distribution of weight of all students is equal to 20 kilograms. Okay. So that is 20 into n minus 1. So that is 10 minus 1. Okay, so the value of chi-square is equal to, chi-square value is 13.999. 13.999. 13.999. Okay, then so this is the calculated value. Okay, so this is the calculated value. So this is the calculated value of chi-square. This is the calculated value of chi-square. So you have to find the table value. Then the next is you have to find the table value of chi-square. Next is find the table value of chi-square. Okay, so for that you need degrees of freedom and the level of significance. So degrees of freedom, that is equal to n minus 1, that is degrees of freedom. Okay, so what is n? So here n is equal to 10. Okay, so that is equal to 9 degrees of freedom, 9. So here the problem is like this. You have to test at 5% level of significance and 1% level of significance. Okay, so level of significance, you have to calculate 5% level of significance and 1% level of significance. Okay, so chi-square value, first chi-square value, so 9 degrees of freedom. Okay, and 5%, what is the value? Okay, similarly chi-square value, again 9 degrees of freedom and 1% level of significance. You have to calculate two values, these two values. So for that I will show the table. Okay, so the value is 5% level of table value 16.92. So we can check. Yeah. So degrees of freedom is 9. So the value is, I will check. Okay, so that is 16.92. Okay, I will write here 16.92, and 1% level of significance is 21.67. So then we can check. Yeah. So here 9 degrees of freedom and 5%, 16.9. Okay, 16.919. So here you can see 9%, sorry, 9 degrees of freedom and 5% level of significance. It is 16.92. Then 1% level of significance, that is, yeah, here 9 degrees of freedom and 1% level of significance, it is 21.666. So 21.666. So okay. So these are the table values of chi-square. Then the next step is you have to compare this calculated value with the table value. Okay. So here you can see we have calculated. So we have calculated the table value. So what is the calculated value? What is the calculated value of chi-square? Okay. The calculated value of chi-square is 13.999. 13.999. Okay. So here, this is the calculated value. So here, this is the calculated value, and these two values are the table values. So these two values are the calculated values, and this is the table value. Sorry, this is the calculated value. Sorry, this is the calculated value. This is the calculated value, and these two are the table value. Okay. So you have to compare these two. Okay. So here you can see the table value is the chi-square table value. So I will write here t. Okay, chi-square t is greater than the calculated value. So chi-square table value is here, you can say 16.92 and 21.67 is greater than the calculated value. Okay, that means your hypothesis is accepted. Okay, so what is your hypothesis? So the hypothesis is sigma p square is equal to sigma s square. Okay, so that means hence we accept, here you can see we accept the null hypothesis. Okay, so the condition is here the chi-square value, chi-square table value is greater than chi-square calculated value, then you have to accept the hypothesis. You have to accept the null hypothesis. So we accept the null hypothesis and conclude that the variance of the given distribution can be taken as 20 kilogram at 5%, also 1% level of significance. In other words, the sample can be said to have been taken from a population with a variance 20 kilograms. Okay, so you have to accept the hypothesis. Okay, so once again, our aim is to the variance of the distribution of weight of all the students from which the above sample of 10. So these are actually sample 10 students. So our aim is to check the variance of the distribution of weight of all students is equal to 20 kilograms. Okay, so that is our aim. Okay, so here first you have to calculate the variance of the sample. So this is the sample data. So here you can see the serial number 1 to 10. These are the 10 students. So first you have to calculate the variance of the sample. So this is the variance of the sample data. Okay, it is 31.11. Okay, then the problem is the variance of the for all students is equal to 20 kilograms. So that is our hypothesis. Okay, that is our test. That is our hypothesis. So here I will write here null hypothesis B, sigma p square is equal to sigma s square. Okay, sigma p square is equal to sigma s square. That means the variance of the sample data is equal to the variance of the population. And then you have to calculate the chi-square. Sigma s square by sigma p square into n minus 1. Here you can see at 5% level of significance and 1% level of significance, what is the value of chi-square? Table value with the 9 degree of freedom. So that is problem number 1. So then next is problem number 2. This is the second question. This is again actually similar to problem number 1. So that's why. So a sample of 10. Okay. So I will take the board. So sample of 10 means n is equal to 10. Sample of 10 means n is equal to 10. Drawn randomly from a certain population. Okay. So you have a population. So you have a population. So you have to take 10 samples. Okay. You have to take 10 samples from this population. Then the sum of the squared deviations from the mean of the given sample is 50. Sum of the squared deviations from the mean. Okay, so you know what is mean. So mean is equal to x bar. Okay, so mean is x bar. Sum of the squared deviations from the mean. Sum of the squared deviation. So you have to find the deviation. So what is xi? So this is the given values xi. So this is the deviation. Okay, and you have to take the square and then you have to take the sum. Okay, so sigma xi minus x bar the whole. In the previous problem you have calculated this xi minus x bar, then take xi minus x bar the whole square, and then you have take the summation. So this value is given here. This value is given. So sigma xi minus x bar the whole square, so that is equal to, it is given. So the value is 50. It is directly given. It is 50. So once again, the sum means, you can see sum means this is the sum. Okay, this is the sum. Okay, this is the sum. Okay, summation sigma, the sum of the squared deviation. So this is the deviation. Okay, this is the deviation. This is the deviation. So here this is the deviation, and here you can see squared deviation. Here you can see square is applied. Okay, squared deviation from the mean. Okay, so this x bar, so this x bar is the mean. Okay, I hope it's clear. So here you can see the sum of the squared deviations, the sum of the squared deviations from the mean, the sum of the squared deviations from the mean. So xi minus x bar. Okay, so the value is 50. So test the hypothesis that the variance of the population is 5. Okay, so the variance of the population is 5. So that is the hypothesis. Test the hypothesis that the variance of the population is 5 at a 5% level of significance. Okay, so here you have to write the null hypothesis. So first you have to write the null hypothesis. Okay, so what is null hypothesis? H naught. So H naught sigma p square is equal to sigma s square. Variance of the sample and variance of the population. Okay, so then what is the value of chi-square? So chi-square equation. So chi-square equation is equal to variance sigma s square divided by sigma p square into n minus 1 into n minus 1. Okay, so what is the value of sigma s square? So that is equal to sigma s square is equal to, so in the previous problem I have explained what is the value of so here you can see sigma x minus x bar the whole square divided by n minus 1, that is sigma s square. So okay, you have to, okay, so sigma s square, so that is equal to, what is the value here? This is 50. Okay, so root of 50 divided by 9. Is it clear? So sigma s square is equal to 50 by 9. Sorry, sigma s is equal to this one and this root. Okay, and sigma s square is equal to 50 by 9. Okay, so that is equal to, we can write here 50 by 9 divided by, what is sigma p? What is sigma p? Sigma p is given as 5. The variance of the population. What is the variance of the population is 5. So that is equal to 5. Variance of the population is 5 into n minus 1. So what is n minus 1? So here n is 10. So that is 10 minus 1. So here the variance of population is 5. It is given. So this is the variance of the sample. So the chi-square value is, answer is, the chi-square value is equal to 10. Okay, so this is equal to 10. Okay, then what is the next step? You have to find the table value. You have to find the table value of chi-square. The table value of chi-square. Okay, so for that you need the degrees of freedom and the level of significance. Okay, so what is the degree of freedom? So here degrees of freedom n minus 1. So the degrees of freedom, that is equal to n minus 1, that is equal to 10 minus 1, so that is equal to 9. And the level of significance, it is given as 5% level of significance, so that is equal to 5% level of significance. 5% level of significance. So what is the table value? So here I will directly write the value, that is it is a 16.92. Okay, so table value of chi-square is equal to 16.92. Okay, so I will show the table. Chi-square table. So here, yeah, critical values of chi-square. Okay, so here you can see the critical values of chi-square. So the degrees of freedom, it is 9. Okay, so degrees of freedom is 9, and then the level of significance is 5%. Level of significance is 5%. So here you can see, yeah, this is the level of significance, 0.055%, and 9 degrees of freedom. So the value of chi-square is 16.919. So that is the value. 16.919 means 16.92. So this is the table value. Then what is the calculated value? Chi-square calculated value. Okay, so previous slide, calculated value is 10. Calculated value is 10. Okay, so you have to compare these two. Okay, table value with the calculated value, and here you can see the table value is greater than the calculated chi-square. Okay, so what is the conclusion? Okay, accept hypothesis, accept null hypothesis, accept null hypothesis. Accept null hypothesis. Okay, so what is the hypothesis? Variance. Okay, so variance is equal to, what is the hypothesis? Okay, 1 minute. Yeah, variance of the population is 5 at a 5% level of significance. So here, here you can see the variance of population is equal to variance of the sample. Okay, so here, here we are actually accepting the hypothesis, because the table value is greater than the calculated value. So we accept the null hypothesis and conclude that the variance of the population is 5. Okay, variance of population is 5 at a 5% level of significance. So this is actually a simple two problems. So in the first problem, you have to calculate the mean, then you have to find the variance of the sample, then write the hypothesis, then apply the chi-square test, and then you have to take the chi-square table value and compare the chi-square calculated value with the table value. Then you can check the null the hypothesis is to be accepted or rejected based on this chi-square value. Okay, second problem is, the here all the values is directly given. So n is given, sum of the square deviation from the mean of the sample, given sample is given. You have to test the hypothesis that the variance of population is 5. Okay, first you write the equations, then you have to write the hypothesis, and then you have to apply the chi-square equation, and then you have to find the value of chi-square at the given here the 5% level of significance, and the degrees of freedom is 9. So the equation of degree of freedom is n-1, that is equal to 9. Okay, so next class I will explain the problems related to chi-square as a non-parametric test. So here, here this is the equation. Chi-square is equal to sigma into observed frequency minus expected frequency divided by expected frequency. Okay, so with the help of this equation, you have to solve the problem. Okay. Okay, so here you have to find the value of sum of observed frequency minus expected frequency, then find the value of chi-square, then find the table value, then you can compare this calculated value with the table value, and then if the table value is greater than the calculated value, then you can accept the hypothesis, otherwise you can reject the hypothesis. Okay, so next class I will explain this this problem, that is chi-square as a non-parametric test. Okay, thank you.